Okay, good morning, Year 5. Now, last lesson we went through the structure of an atom, didn't we, and learned all about its particles. Now, this lesson, what we're going to do is going to have a look at how these particles relate to different elements in the world, okay? So, let's get ready to go. Before we continue, what I want you to do is write the lesson objective and the date, please. So just pause the presentation here before continuing. Okay, now just to start off, what we're going to do is have a little recap of the atomic structure, okay, it's from last lesson. So please draw this diagram in your books and try and remember the particles that make up an atom. So you might want to have a little look back to the work that you produced last lesson and see if you can label the atom correctly. So this diagram might be a little tricky to draw. So what I want you to do is just draw the rings just going around like this, so they don't have to cross over, okay? That'll make it slightly easier. So can you pause the presentation here and try drawing your own atomic structure? Okay, so now with your purple pens, can you correct any mistakes that you might have made? Okay, so we'll start off with, first of all, the nucleus. So that's the clump of particles here made up of neutrons and protons. Now you might have thought, oh, how can I sort of differentiate between the blue and the silver particles? Now remember, this one was labeled as no charge, which is obviously the neutron, and this one was labeled as positively charged, which is the proton. And the particles which swirl around the middle of the outside of the nucleus are the electrons, which are negatively charged. So just pause the presentation here if you need to correct any changes in your purple pen. Okay, what we're going to do now is a quick 2-minute challenge. Okay, so can you please write the heading here, metals and gases. Now, in 2 minutes, can you try and write down as many metals or gases that you may have heard of? Okay, so any metals and gases that you might have heard of. Can you pause the presentation here? Find something that you can time yourself with for 2 minutes if you can, and write as many as you can think of before going on to the next slide. Okay, I'm looking forward to reading your metals and gases list. Now this here is what we call the periodic table of the elements. Okay, now this table itself consists of all of the substances and elements that scientists have discovered, okay, so far in the world. Now these make up everything that you see all around you, and they're color coded as well. So let's just take this large chunk of yellow elements here. They're called transition metals. So we've got metals, basic metals, and then up here you'll have the non-metals, so the gases and noble gases. So for instance, there's oxygen here, nitrogen, carbon, and you might have heard of a few of those. So this is what scientists use to map out what everything in the world is made up of. Now, what is an element, you might ask? Now, an element is a substance entirely made up of one type of atom. Now, this is how it links in to what we've been studying, okay, over the past couple of lessons. So elements you may be familiar with are copper, oxygen, and gold. And elements come in all states of matter, liquid, solid, and gas. And the atoms in each element are different because of the amount of electrons, protons, and neutrons they have. So everything in all the elements and every sort of substance and everything with mass that we've been looking at so far is made up of atoms. Okay. Now, what makes an element different is that all these atoms look differently. Okay. So then when they're put together and when they sort of build up to make the elements, they look completely different. So let's move on here. Now, what you might be asking, what do you mean by the look difference? So now we need to have a look at the atomic structure. So using the periodic table, okay, you can work out what an element's atom looks like. So for instance, okay, this is the atom that we were looking at earlier on. Now for each element, there are a different number of electrons, protons and neutrons which make up the element. So for example, we have helium here. This is how it's depicted in the periodic table. So we've got a mass number, its chemical symbol, so helium, He stands for helium in the periodic table, and we've got its atomic number right here. Now looking at this, it might look a little bit confusing, but it's actually quite easy using this little box here. Okay. Now the number of protons in an atom is equal to the atomic number. So the atomic number is here. So helium has 2 protons. The number of electrons is also equal to the atomic number. So the number of electrons in helium are 2. There are 2 electrons in helium. And the last one, the number of neutrons. So how we can work out the number of neutrons, in this case helium, we do the mass number minus the atomic number. So the mass number is here and the atomic number is here. So it's 4 minus 2, which is 2 as well. So the number of neutrons in a helium atom is 2. Okay, now although we've just gone through how to work out the proton, electron and neutron number of helium, I want to give you a little chance to give it a go yourself. So what I want you to do is, this is how I want you to set it out in your books. Okay, so I want you to put the heading helium, and then write the chemical symbol, which you'll find here. And then I want you to put write protons, electrons and neutrons, and write the correct number next to each of the particles. So remember, to work out the number of protons in this case a helium element is just equal to the atomic number, which is here. Number of electrons are equal to the atomic number also, and the number of neutrons are equal to the mass number, which is found here, minus the atomic number, which is found here. Now, this is how I want you to lay it out. So can you pause the presentation here and complete the work for the helium element? Okay, now that you've worked out the atomic structure in a helium atom, what I want you to do now is look at this section of the periodic table here. Look at this little table. Now what I want you to do is work out the atomic structures of 5 of these elements. I just want you to choose any 5, and please include its chemical symbol. But what I don't want you to do is don't try and work out chlorine, and we'll come on to reasons why later on. Now I've put this table here to remind you as well that the number of protons equals the atomic number, the number of electrons equals the atomic number as well, and the number of neutrons equals the mass number, which is here, minus the atomic number, which is here. Now remember, this little box here is just for the helium atoms. Now if you'll notice, boron, for example, has a different mass number and atomic number. Okay, so just bear that in mind. Now if you were to choose boron, for example, as one of your 5 elements to work out, this is what I want you this is how I want you to set it out in your books. Okay, so similar to the helium atomic structure, you just write boron, then the chemical symbol, protons, electrons and neutrons. If you need to do any working out, just do it right next to it in the space. Right, so if you can pause the presentation here and work out 5 of these elements. Okay, great. Okay, now thank you very much for doing that. Now what we're going to do now is have some word questions, okay, related to the atomic structure of elements. Now what I want you to do here is, first, can you pause this presentation here and can you draw this table in your book, because this is the table which is going to help you with the upcoming questions. So pause the presentation here and draw this table in your book, please. Okay, now that you've done that, that's great. Now let's have a look at number 1 as an example of a word question which is upcoming. Okay, neon has an atomic number of 10. How many protons are there in an atom of neon? Now the difference between this question and the previous question about helium, for example, or the 5 elements that you've chosen, is that we don't have the cutout from the periodic table. But don't worry, because we have this table to work it out, don't we? So the number of protons is equal to the atomic number, the number of electrons is equal to the atomic number, and the number of neutrons is equal to the mass number minus the atomic number. So we can use this table to work out all the answers in the upcoming word questions. So neon has an atomic number of 10. How many protons are there in an atom of neon? So the proton number is the same as the atomic number. And look, we've found out here that the atomic number of neon is 10. So how many protons are there in an atom of neon? 10. So how I want you to set it out in your book, can you now pause this presentation and write the heading word questions? And the answer to number 1 is neon has 10 protons. I want you to answer these word questions in full sentences. So can you pause the presentation here and write the heading and the answer to number 1? Right, that's great. Thank you very much for doing that. Now, here we have word questions 1 to 4, and on the next slide, there are 5, 6, and 7. So what I want you to do is pause the presentation here and complete the questions underneath your heading. Once you've completed 1 to 4, move the presentation on and do 5, 6, and 7. Okay, that's great. Remember to answer the questions in full sentences, please. And here we have questions 5, 6, and 7. I'll pause the presentation here and complete 5 and 6 and 7. Remember, using that little table that we drew earlier to help you. Right, plenary. So this is the final little part of the lesson. Now, looking back at the chlorine element, which I asked you not to work out, what is strange about its mass number here? Now, how could this be problematic? Using the table that we've been using to work out, you know, the proton number, neutron number, and electron number. So can you please write an explanation of what you think? So chlorine's mass number is problematic because, why do you think? So pause the presentation here and write your answer. And then after that, that's great. We've finished today's science lesson. So looking forward to seeing your answers, and I'll see you very soon.